Welcome back. We're going to be talking about solving systems of equations in three variables. So we're expanding from just x and y to x, y, and z. And a solution for something that has three variables is going to have a word triple, which is going to look like x, y, and z, like so. So if you have three variables, if you're trying to graph something like that, you're graphing in space because you have length, you have width, and then you have depth. So um, our graphs, if we were to graph it, is going to end up being planes. And so if you were to, let's say, just graph in 2 dimensions, a single solution would be where the lines cross. But in 3 dimensions, we're looking at where the planes cross. And we're not just dealing with 2 planes, we're dealing with three since there are three variables. So for instance, if this would be the situation here, and where you would get one solution, and all three planes intersect at a single point, and that would be the solution for all three. If all three planes intersect along an axis, like here, this would be the case where you would get infinite number of solutions because the planes extend infinitely, as does the line extend infinitely. But there are several different ways in which you would get no solution. Remember, all three planes have to intersect at some point. And in this case, we always have two planes intersecting each other, but never where all three are. Uh, this situation in the middle, we have an intersection here and here, but the green and blue planes never intersect. Or all three planes could be parallel to each other, and there'd be no intersection. So all three cases here, that would be no solution. So let's take a look at how we can find a solution or how we would solve these. Now, graphing those is very difficult, and we're not going to be able to graph them, in 3 dimensions. That's just, a little bit beyond our ability at the moment. So, and it's a lot easier to solve it algebraically. So here, where I have three variables, because you have three variables, you need three equations. So for each variable you tack on, you need an extra equation. So if we have one variable, we just need one equation. If we got two variables, we can solve with two equations. Three, we need three. So um, the method I'm going to choose to do, which I feel is probably the easiest, is elimination. So let's take a look at elimination for this. Now, looking at this, we can choose to eliminate either x, y, or z. It doesn't really matter which one we choose. Except in that we want to find something where they are easily multiples of each other, or they have at least common multiples that are easy to use. Um, and that's the reason why I'm going to go ahead. I mean, and you could use x would be a good choice, or y would be a good choice. For this, I'm going to use y. I think it might be a little bit easier to use y. So let's start off. What I'm going to do is I'm going to pair up these equations. So I'm going to take the first two equations and eliminate y. So I have 2x minus y plus 6z is equal to -4. And 6x plus 4y minus 5z is equal to -7. All right, so if I'm going to eliminate y here, I need to have the same coefficient on both, and the signs need to be opposite, one positive, one negative. So I already have one that's positive, and I have one that's negative. So I'm going to go ahead and multiply this by 4, the top one, and that's going to leave me with 8x minus 4y plus 24 z equals negative 16. So I'm going to add these together. And let's see, we'll be given 14x. The y's cancel. And we'll get, let's see, that's going to be 19z. So plus 19z equals negative 23. Okay, so we're going to hold on to this equation here. All right, we're going to come back to that. And we're going to pair up the other two equations, the second and the third. It doesn't matter. You could do like the first and the second and the first and the third. It makes no difference as long as you eliminate the y variable on each of them. So I could have done, instead of doing the second and third, I could have done the first and third, as long as I've used all three. Okay, so this is going to be 6x plus 4y minus 5z is equal to negative 7. And that looks like a y. Negative 4x minus 2y plus 5z is equal to 9. So I'm going to multiply the bottom one by a positive 2. So positive 2 here and positive 2 here. Okay, so I'm going to end up with negative 8x plus 4, minus 4y, my mistake, minus 4y, plus 10z equals 18. All right, let me bring down the first equation, the 6x plus 4 plus 4y minus 5z is equal to negative 7. Now let's add these together. So I'll be left with negative 2x, the y's cancel like we wanted, plus 5z is equal to 11. All right, now we have a second equation. So now we're going to go back and refer to the first one, and we're going to take these two and we're going to eliminate another variable. So let's see, we had 14x plus 19z is equal to negative 23, and negative 2x plus 5z is equal to 11, like so. So we need to make a decision on what we want to cancel out, eliminate. In this case, the x's will be easier because you can multiply 2 with 7 to get 14, whereas it'd be harder to find a least common multiple between 5 and 19. So I'm going to go ahead and multiply the bottom equation by 7. So I'll multiply this by 7 here and here, and we will be left with negative 14x plus 35z is equal to 77. Bring down the first one, 14x plus 19z equals negative 23. Let's get a little bit more space here. All right, so we'll add these together. All right, these cancel. And we're going to be left with, let's see, it's going to be 54z is equal to 54. Yeah, 54. It works out nice. Okay, so we divide both sides by 54, and we have our first variable. Z is equal to 1. Okay? Now it's pretty easy to get the rest of them. So now that I know what Z is, I can substitute Z into one of these two equations. We can do one of these two here and substitute Z and then find X. I'm going to use the one with smaller numbers. I'm going to go ahead and use the negative 2x plus 5z equals 11. So it's going to be negative 2x plus 5 times 1 is equal to 11. So that's negative 2x plus 5 equals 11. And we subtract 5 here and subtract 5 here. So negative 2x is equal to 6. Divide by negative 2. And we'll have x is equal to negative 3. Okay, so we have our z value of z equals 11, or z equals 1, sorry, and x equals negative 3. So now what we're going to do is take we're going to take these two variables, substitute it into one of the three original equations that we started off at the very beginning. So let's go ahead and use, it doesn't matter. I'll do the first one here. Okay, so we said that 2x, so 2 times negative 3 minus y plus 6 times 1 should equal negative 4. So that's going to be negative 6. Let me kind of partition this off. So negative 6 minus y plus 6 equal to negative 4. The 6's cancel. So we're left with negative y equals negative 4, or y is equal to 4. So finally, we can write our ordered triple. It's a point in space, which would be negative 3, 4, and z is 1. And then we can finally box in our answer. So anyway, as you can see, when you add another variable in, you can add to the amount of work it takes to get there considerably. So imagine what that's like if we were to have 4 variables or 5 variables. Something to think about. We're not going to do that this way anyway. We're just going to leave it at 3 variables. So you get the idea. Anyway, that's solving system in 3 variables. And I think one example is enough.